Hey guys, Becca here today, and we are going to talk about finding derivatives using the chain rule. So hopefully if you're watching this video, you have some background knowledge on how to find basic derivatives, but in this video we're mostly going to cover how to use the chain rule, when to use it, and it's going to be extremely useful throughout your journey through calculus. So to start, we're going to have just a quick refresher over finding basic derivatives. So these do not involve the chain rule. These are just to get your brain warmed up and going. So for our first one, we have 7x, and there's an imaginary 1 over that. So that imaginary 1 exponent is going under the 7, so it's just 7, and then you subtract 1 exponent. You subtract 1 from your exponent, and it becomes x to the 0th power, so it goes away. So you're left with a derivative of just 7. And then for our second example, we have x squared plus 8, and the 8 also has an imaginary 1 exponent over it, and that exponent goes down, becomes 1 times 8, and you subtract 1 from the exponent, making it 8 to the 0th power, making it completely disappear. Then you have x squared, and then you take the 2 down, so it becomes 2x, and then you subtract 1 from the exponent, so it just becomes 2x with an imaginary 1 as an exponent. Then for this final refresher problem, we have 2x cubed plus 5x squared minus 9. So the 9 disappears just like it did the other numbers did without any x or exponent for that matter. And you have 5x squared. The 2 multiplies times the 5, and you subtract 1 from the 2, and then you have 2x cubed, and this 3 times 2 is just 6, and you subtract 1 from that 3, making the exponent there too. So it becomes 6x squared plus 10x. So hopefully that was all really simple for you, that was familiar. If not, and you're still really struggling to find basic derivatives, I don't recommend continuing on with this video, but if you're totally ready, then let's go right into the chain rule. So to start, I'm just going to go over the basic steps of the chain rule. It's not going to make a lot of sense at first without examples, but we will have examples. These are just our guidelines that we're going to use throughout our examples. So first, you're going to identify if you need the chain rule. So when do you need the chain rule? You use the chain rule whenever you see something in parentheses that's extremely important. Whenever you have one function, just one, and it's in parentheses, and it is squared or it's brought to a higher power. So if it's a polynomial, it's in parentheses, and the whole thing is brought to a higher power, is when you will need to use the chain rule. So in order to calculate this using the chain rule, you're going to have to temporarily treat what's inside of the parentheses as its own variable. So you're going to treat that as its own independent thing, ignore everything else for a short amount of time. You're going to calculate the derivative of the inside and bring that outside to the front, leaving the original polynomial there. And you're also going to bring the exponent out to the front. You're then going to subtract 1 from the original exponent, which is part of finding the derivative anyways. So that probably didn't make a bunch of sense, but now we're going to apply it to an actual problem. So for our first problem, we have f of x equals 8x plus 4, that is all squared. So the first step is to treat 8x plus 4 as just x, and then find the derivative of that. And you should be able to figure out pretty quickly that the derivative of this is just 8. Then we bring the derivative outside, leaving the original polynomial there. So we have 8 times 8x plus 4. And we're also going to bring the exponent out front to multiply the taken derivative. So it's going to become 8 times 2 with the rest of what we already have, which is 16 8x plus 4 squared. But you're not done there. You're going to have to finish off with subtracting 1 from the exponent like you would have to with any other derivative, leaving your answer as 16 8x plus 4. So hopefully you got that. If not, it's okay. We're going to go over a couple more problems and you will understand this eventually. So for our next problem, we have 2x cubed plus 7 all raised to the 4th power. So just remember to find the derivative, you're just going to find the derivative of what's on the inside. So 2x cubed plus 7, you're going to put that out front, leaving the original polynomial, and you're also going to bring the exponent out front. That'll multiply the derivative that you've taken out. And then lastly, subtract 1 from the exponent on the outside of the parentheses. So you can pause here, try this problem on your own. If you don't get it, it's okay. We are going to go over how to do this specific one. Okay, so for f of x equals 2x cubed plus 7 all raised to the 4th power, we have 24x squared times 2x3 plus 7 all cubed. So how we got this was first we found the derivative of what's on the inside. So 2x cubed plus 7, 7 goes away, and then the derivative is 6x squared. So we take out the 6x squared and bring it to the front. Then we take our 4, which is our exponent in this problem, and also take it out to the front, multiplying times 6x squared, which just becomes 24x squared. Then lastly, you subtract 1 from our original exponent, and you will end up with 24x squared times 2x cubed plus 7, which is all raised to the 3rd power. The inside of the parentheses is all raised to the 3rd power, I should say. One last problem. We are going to have f of x equals 4x to the 6th plus 8, all raised to the 3rd power. So just like in all the other problems we've done, we're going to find the derivative of the inside. That should not say 2x cubed plus 7, that should say 4x to the 6th plus 8 to the 3rd. My apologies there. Just use what's at the top. So solve the inside of the top, so 4x to the 6th plus 8, and put it out front. Then you're going to leave the original polynomial there. Also, remember to bring the exponent, which is 3, out to the front, multiplying the derivative and the exponent that you brought out to the front. And lastly, subtract 1 from the exponent on the outside of the parentheses. So, your answer should be 24x times 4x squared plus 8 squared. So how we got this was we took the derivative of the inside, always our first step, and 8 goes away and it just becomes 8x. So we bring the 8x out to the front. Then we bring the exponent out to the front as well. So we bring 3 times 8x, which just equals 24x. And we also remember to leave the polynomial that we've been working with there. And then we subtract 1 from the exponent up at the top, and we are left with our beautiful answer. Alright, nice work, team. Just remember to love life, love math, and most importantly, love cats.